All right, so we're going to start today by getting all of our data first. We're going to fill in all of our tables first, and after we fill in our tables, then we'll go back and answer the questions about each table. But I want to get all the tables filled in first. Is that okay?
Yeah.
All right, so we're going to start right here. We're going to start with this equation. So in your calculator, first of all, turn it on. Start a new document if you need to. No, we don't want to save the old one. We want a graph for our workplace. Okay. So for our first table, we're going to put in 3 times 2 raised to the x power. Now it's all fine and good to look at the graph, but what we really need is the table. So Control T. Very good. Okay. So Control T. Jake, you ready to start? You tell me when. Yeah, I'm not mad. You're fine. Now, when you're filling out these tables, what I want you to be careful of is when you notice, please, when your table comes up, the very first one you can see is 1, but the very first one we need is 0. Okay? Yeah, so you push up. That's exactly right. So, you ready? Go ahead.
3, 6, 12, 24, 28.
Okay, so hold on. Jake said 3. Kalia said 6. Who said 12?
Me, I thought it was 3rd.
Are you skipping? You can't skip.
Sorry, I'm sorry, Mom. I said 24.
Okay, so we're going to count you as saying 12,
Okay.
and Abby is saying 24, and then who's next?
48.
Okay. Now, we have another table to go to.
How do I get the table then?
Control T. Yep, Control T is how you get to the table. Sorry, I think I said that, but maybe you didn't hear me, and I should have checked to make sure. Okay. So now we need to go back here and say Control T again to make the table go away. I need to press Tab to make the equation come up, and then delete it and put in my new equation. 2 times 3 raised to the x power.
Wait, why are we... Oh, okay.
Remember, all we're doing is filling the tables first, so we can go back and fill in the information second. We're just gathering all our data first. So Control T takes me to the table. Felicia, whenever you're ready.
2,
Okay.
6,
Thank you, Sierra.
Wait, 2...
Okay, thank you.
Miss Kingston, I did something wrong.
Okay,
Oh,
what
no,
can I do to
didn't.
help?
54.
54, okay.
62.
62, okay. Come and get this for now. I'll need it back in a second, but come and get it for now. You're welcome. All right, now we're at a new table.
2, 6.
Y equals 6 to the x power. Jake, you tell me whenever you're ready, okay?
Go back.
Now, do you think, especially on this one, you think we could do some of these in our head?
Probably.
Probably, okay. But that's okay.
Okay. 1.
1,
6,
6,
36,
very good.
2, 9, 16,
Okay,
1,096.
very good. Now to the next table. Y equals 8 times 0.5 to the x power. Alicia, whenever you're ready.
8, 4,
Thank you.
2.
Good.
1.
Okay,
5.
very good. Everybody okay so far? Okay. Table number. I'm sorry?
I said it just takes me a minute to get there.
That's fair. I'm not rushing anybody. We just want to get our data and we want it correct, don't we? Okay. So now go to table number 5. We have y equals 100 times 0.5 to the x power. Jake, whenever you're ready. Excuse me. 100, very good.
50.
Thank you. 50. I'm sorry?
25.
25.
12.5.
12.5.
6.25.
6.25. And our last table here on the front of the page. We have y equals 200 times 0.8 to the x power. Felicia, whenever you're ready.
200.
200, 160,
160.
128.
128,
102.4.
102.4,
81.92.
81.92. We good?
Listen.
Yeah, God bless you. So everybody have all the tables copied down? Yes? Okay, so let's go back up to the first table. Notice what it says in the directions. The basic form of an exponential function is y equals a times b to the x. Is that the equation we used yesterday? No. Okay. What was the equation we used yesterday?
Equals A plus 1.
Plus or minus, right? We did sum of both, plus or minus r to the t power, right? So a is the rate, t is the time, right? Do you think that these two equations are related? Not only are they, but I will prove it to you by the end of the period. Is that fair? Okay. All right, so that's the one we used yesterday. Here's the one we're using today, y equals a times b to the x. Okay? Well, if it's a times b to the x and I tell you y equals 3 times 2 to the x, can you tell, whose turn is it, by the way? Jake? Jake, can you tell me what a is for this problem? 3. And Clea, can you tell me what b is for this problem? 2. Okay. Now, just something real quick so we can get our blanks filled in. I'm sure it's not going to mean anything at all. What's 6 divided by 3? Isn't that how you get a common ratio? So Kirsten said 6 divided by 3 is 2. Abby, what about 12 divided by 6? Abby. Yeah, your voice is so deep compared to how it normally is. 2? What about 24 divided by 12? Who's next? 2. And 48 divided by 24?
2.
Okay. Look at problem number 2. If y equals 2 times 3 to the x, Sierra, can you tell me what a is for this problem? 2. Okay. And Isaiah, can you tell me what b is for this problem? 3. Okay. Aiden, what is 6 divided by 2?
3.
Okay. Well, what's 18 divided by 6?
3.
And 54 divided by 18? Yes. And 162 divided by 54? Clea? 3. Okay. So right now we're filling in our blanks and we're in thinking mode, right? We're like, that's interesting. That's interesting, right? Okay, look at problem number 3. Kirsten has the hardest problem of the entire day. Not really. It's not straightforward though, right?
6.
What is a in this problem?
6. Maybe what?
Y equals a times b to the x? What is it? It's one of those two, right? It's either 0 or 1 because there's not an a written. And usually if there's not an a written, it's usually either 1 or 0, right? What is a doing to b to the x power? Multiplying. So if I multiply by 0, that would be bad news, right? So what is a for this problem? 1. And Abby, what is B for this problem? 6, very good. And what is 6 divided by 1? Okay, and Felicia, 36 divided by 6?
6.
Sierra? 216 divided by 36? Isaiah, 1,296 divided by 216? You didn't even do that. Did you? Oh, remember, we're just saying, right? That's interesting. Right? Okay, good. All right, who's next? Jake. Oh, sorry, did I skip you? Sorry. Okay, so what's A for this problem? 8. And what's B for this problem? 0.5. Okay. Kalia, what is 4 divided by 8? You're fine. 1/2, okay. What is 2 divided by 4? You're fine. 1/2. What is 1 divided by 2? Abby? 1/2. And 0.5 divided by 1? Okay. What's up?
Would you rather have a ratio?
Oh no, I just wrote down what you said.
Okay.
I just wrote down what you said. You're fine. You know, if it was wrong, I wouldn't write it down, right? Okay, but I wrote down what you said. To be fair, we'll talk definitely about that when we go back to really focus and study on all these. Okay. Okay, who's up? Okay, so what's A for this problem? 100. And what's B for this problem? 0.5. Excellent. And what is 50 divided by 100? 0.5. And what is 25 divided by 50? 0.5. And what is 12.5 divided by 0.5? Sorry, 12.5 divided by 25? 0.5. And 6.25 divided by 12.5? 0.5. Again, very interesting, right? Okay. I mean, math interesting. Right, okay, that's fair. What is A in this problem? 200. And what is B in this problem? 0.8. Okay. Uh-oh, I used the wrong color. Dang it. 0.8. What?
Why would we need to know what A and B is? Like, how are we using that?
Can I tell you that in a second? Thank you. 160 divided by 200. Four fifths, okay. 128 divided by 160. 4 fifths. 102.4 divided by 128. Tell me what it says. Don't be swayed by the people around you. You tell me what it says. 0.8. 81.92 divided by 102.4. 0.8. Okay. Now that's the only time we've written something different, isn't it? Okay.
Not really. I mean, it's the same
Not
thing.
really, but it's the same thing, right? But it's still a little bit different, isn't it? Okay. So let's go back up to number 1, because we have some questions to answer on the side, but I want to make some observations first. Okay. Did you see this ratio anywhere? Did you see this ratio anywhere? And did you see this ratio anywhere? And this ratio? Really? Like, really though?
I mean, same thing.
No, but yes, right? We wrote down 1/2. And why did I write down 1/2? Because she said 1/2, right? You are smart enough to know that 1/2 is the same as 0.5. We're good, right? Okay. And then did you see this ratio anywhere? And then did you see this ratio anywhere? Now you already told me that 0.8 is the same as 4 fifths, right? So why did you say 4 fifths right here, and why did you say 0.8 right here? If you divide 160 divided by 200, the calculator will tell you 4 fifths. But if you divide 102.4 by 128, it will tell you 0.8, because you had a decimal point in the problem. When you put it in, it's going to give it to you as a decimal. There was no decimal point decimal points here, so it gave it to you as a fraction. You okay with that? Now, where does the a value show up in the table?
0 in the first line.
So how can we say that so it's true for every single time that we write it?
When y equals 0.
When what equals 0?
X.
When x equals 0. That's exactly right, though. When x equals 0, that's where a is in the table. The y value is a, isn't it? Isn't it true for every time? Here, and here, and here. It's true every time, isn't it? Okay? What effect does the b value have on the table?
It's the rate of change.
Or
Ratio.
it's the ratio. Now, for the record, I didn't say rate of change because rate of change is usually like a slope, right? And this isn't linear, so I'm just going to keep the word ratio. Does that make sense? Okay. I knew what you were saying. That's why I just asked you to fix your vocabulary.
Because that's how it changes.
No, yeah, you're fine. That's exactly right, though, isn't it? Okay. Any questions so far on what we've talked about so far? If I give you a table, can you automatically tell me the equation it came from?
This information.
With enough information, right? But I told you if I gave you the table, is that enough information? Yes? Where do you look for A? When x equals 0. And where do you look for B? Yeah, you might have to do some mental math there, right? Okay. But yes, you have enough information, right? So let's get this down. A is the
Y or X value.
it's the initial amount or starting amount. But you very clearly said when x equals 0. I heard you. Yes, that's good. Okay, when x equals 0. It's the initial amount or starting amount when we start the table at 0. Okay, and what is b? It's the ratio. But underneath b, talking about b, turn back to your tables real quick. When is the y value increasing? What's true about the b value when our y values are increasing?
It's a whole number.
What do you mean by that?
Like it's more than 1.
Oh yeah, that's perfect. When b is greater than 1. When are the y values decreasing?
B is less than 1, but then
So that is very true, right? You have enough information on the tables to be able to tell me it's when b is less than 1. But you also know, because we've talking about this for a couple of days now, that b also has to be
less.
greater than 0, right? So less than 1, but greater than 0. Excellent job. Excellent. So can you go backwards? Remember, I asked you a second ago, you said yes, so let's prove it. Here's the table. Where are we at? Do you know whose turn it is?
No, it's probably mine.
Okay, let's start with you. What's 20 divided by 5? 4. What's 80 divided by 20? 320 divided by 80? 1280 divided by 320.
Oh, I'm sorry, 4.
4. So Abby, what does that tell you? 4 is B. Very good. And what do you know about A? So Felicia, can you tell me the equation? That was her question. She just didn't answer it. Yeah. No, yeah, it's your turn.
5,
5,
and then 4.
4. Now, can you tell that there's an exponent right there?
Yeah.
It's really, really tiny. And so if you're uncomfortable with the size of that exponent, just try to write yourself another one. I just don't want you to miss it. Does that make sense? Okay? Who's up? Isaiah? Sierra? What's 18 divided by 9? How about if I tell you the answer? What's 18 divided by 2? 9. 162 divided by 18? 1,458 divided by 162? 9. 13,122 divided by 1,458. Okay, so I'm going to make a comment to Jake because I know he can handle this. Jake, you didn't even do that. Is that a good thing or a bad thing?
Both.
It's definitely a good thing because why? What did you see?
I saw it come that.
You saw the pattern, didn't you? Okay, did you guys see the pattern? Is that okay? Because the first 3 people, I watched them pick up their calculators and put this number in. Now, Sierra didn't because she knew what 18 divided by 2 was, right? But the rest of them, I think it's probably 9, but where I'm going to check, right? Jake didn't even check. But that is not necessarily a bad thing because Jake saw the pattern.
But what if it isn't?
So if the table is given to you already and I'm telling you it's an exponential function, what's going to be true about the table? It's going to be right. Yeah. I appreciate you worrying about that though, right? If I'm asking you to verify that it's an exponential function, you better be doing all the division, right? But right now I'm just saying what's the equation because I'm telling you it's a good table. Is that fair? Okay. Whose turn is it? Okay, so what is B then? 9. And what is A?
2.
And how do you know that? Right there. So, Abby, what's the equation? To the x power, right? Excellent. All right, 24 divided by 16. What's it say? 1.5. 36 divided by 24. 3 over 2. 54 divided by 36. 3 over 2. 81 divided by 54. 3 over 2. So now it's your choice. What are we saying is B?
1.5.
Why? Why would you choose that?
I think decimals are easier than that.
So that is your
Personal.
personal opinion, right? Does everybody understand that? So would some of you rather have 3 halves right here? Yes. If you would rather have 3 halves right here, write 3 halves. I'm writing 1.5 because it was his turn, and that's what he said. But is 3 halves a perfectly acceptable answer right here? Yes, good. Okay. Jake, what's A?
1 out of 16.
And how do you know that? Good. So, what is the equation?
16 and 1.56.
Excellent. Okay, so far? 200 divided by 500. What? 0.4? 80 divided by 200. 2 over 5. 32 divided by 80. 0.4. 12.8 divided by 32. 2 over 5. Sierra, what do you choose for B?
4.
Sierra, why can you choose for B?
Because there's 2 choices on the table.
And they are both
The
the same, right? They're equal. Okay, so you're saying you want 0.4? I'm fine with that. And what is A? 500 because how? Because why? Right, good. And so what is the equation?
It's going to be A is 500 and B is 0.4.
Okay, so far? Okay. Can I have a turn for a little bit? Just a little bit, and then we'll go back to your turns in just a second, okay? So I'm going to put in my calculator, then the next thing it asks us to write the rule for. So I'm going to say, make my table go away, tab to get the equation up. 4 times 1 raised to the x power. Okay. 4 times 1 to the x power. What if x is 0? What's anything to the 0 power? 1. And what's 1 times 4? 4. I won't make us go around the room if I'll answer. Is that fair? Okay. What if I put in a 1 right here? What's 1 to the first power? And what's 1 times 4? 4. And what's 2? If I say 1 squared, what's 1 squared? 1, right? Because it's 1 times 1. Times 4? 4. Okay, 1 to the third power? Still 1 times 4? That's what the graph looks like. Anybody see a problem with that graph? It's definitely not exponential, is it? What is it? Yeah, it's a line, isn't it? Is it okay if we just say right now and come back in a minute? Okay. Because this is the one I really want you to see. Okay, let's see. 4 times negative 2 to the x power. So if it's 0, anything to the 0 power is what? 1. 1 times 4 is what? 4. Okay. Negative 2 to the first power. Negative 2. Negative 2 times 4? Negative 8. Okay. Negative 2 squared. So negative 2 times negative 2? 4, right? And what's 4 times 4? 16. What is negative 2 to the third power? Negative 2 times negative 2 you said was 4 times negative 2? Negative 8 times 4? Negative 32. Okay, I really, really want you to see for the graph for this. Okay, so would you respectfully stop what you're doing and look? Tab. So it's negative 2 raised to the x power. Okay, keep watching. Keep watching. Keep watching. Keep watching. A little bit more. Little bit. There we go. So can I explain this real quick? Okay, so the technical mathematical term is that your calculator freaked out. Okay? What's happening with my y values right here? Back and forth. So it's trying to go positive, negative, positive, negative, positive, negative, positive, negative, positive, negative, ah! And it freaked out. It tried to connect all those points. Is that what we wanted it to do? Not at all. So what do you know about this? Also, not exponential. Okay? Because it alternates signs on its y values. Do any of the tables have we done so far have the y's alternated signs? No. Okay? That's one of the reasons we don't deal with negative bases. Okay? So why do you think we usually don't use these values for b? They are weird. And then please also include a frowny face. I'm mostly teasing about that part. Okay. Now, on the back, what I'm going to make sure to do on the back is make sure you have both equations. Okay, for both problems right here. And then when I make sure you have both equations, I'm going to start on the first problem and we'll get as far as we get. Okay? To help with the cost of tuition, room, and board, and you take out a loan of $20,000 for college, you do not have to make any payments on the loan until you leave school. However, the loan amount accumulates interest at a rate of 12% annually. That seems like we need yesterday's equation. But remember I told you, we may not even have time to finish this part, but I'm going to tell you anyways. Remember how I told you I would connect these two? Didn't we already do that without even me telling you? What do you know about if I add R? Definitely exponential growth. What if B is greater than 1? Exponential growth. What if I subtract R? Decay. And if B is between 0 and 1? Decay. Okay? So, I start with how much money?
20,000.
So what is that in my equation? That's my A. So 20,000. And what's my B? Well, if I think of it as B, maybe I don't know, but if I think about it as 1 plus or minus R, and if this money is accumulating, what does that mean? It's filling up, right? So I'm going to add R. So what is it going to be? 1. Is it okay if I just put 1.12 to the x power? So you'll use this equation to do table, graph, and answer the questions. Use your calculator to help you answer the questions. The bottom one, I just have to make sure you have the equation because I don't want you to mess up. This is $20,000 you borrow for the car, but it loses 20% of its value every year. So what is this value? 1 minus 0.2, which is 0.8. Does that make sense to everyone? Any questions?